Okay, so good day, grade 8 Makati Science High School students. I'm Sir J.M. Padre and I'm going to be your teacher in geometry. And for today, we're going to be learning a lot of new stuff, okay, for our lesson, for our first lesson here in geometry. But first, I'd like to introduce to you guys a method that you can use to solve problems, and not just in geometry, but all problems in mathematics or also in science related problems that involve numbers that you can use. Okay, so for our first lesson, we have the angle addition postulate in geometry. So we have this method that I'm going to introduce to you guys. It's called the PUSA method, or you can call it the PUSA method. Okay, so first we have to identify the problem. Okay, so we have to identify the problem that we have to solve for our given for the given situation that you have here in solving problems in geometry. Then the second step is to have to understand the problem. So what are we trying to solve in this problem? Are they asking for a specific unit, or are they asking for 2 units, or free answers? They're asking for free answers, so we have to specify that. Okay, so that's our second step. The third step is, of course, the most important step, the solution phase, or we can also call this the strategy phase. Okay, so for the third step, we have to identify a solution or a way to solve the problem. Now that we've understood what they're asking for and the specific problem, we have to kind of find like a strategy to solve this given problem that we have. And there are, as we're going to see, guys, in our future topics, there's going to be a lot of solutions. There's not one solution to a problem. There are many solutions, and all of them are valid so long as that they give the same answer that we're trying to look for. And of course, in math problems, there's going to be the answer. So the answer could be, sometimes there's going to be just one correct answer, and sometimes there might be two correct answers. Like say, for example, when you have quadratic equations, you're going to have positive answers and then negative answers. So we're going to see more of those, okay? We're going to see more of those in our next lessons. Okay? So for now, okay, let's go to our first problem. Okay, we have here Alexandria wants to measure the distance between her house, her regular comic book store, and her local grocery. So given the illustration below, and AB is equal to 2/3 of BC, find the distance between her house and her local grocery store. So we have here illustrated on screen, from points A to B, we have Alexandria's house, and then the comic book store, it measures x plus 3 meters. And then from points B to C, we have the comic book store, and then going to Alexandria School, which is 3x minus 6 meters. So how are we going to solve this problem? Okay, the most important part here, of course, is from our first step. We've already identified the problem that's been given to us. Second, we have to understand the problem. What are they trying to what are they trying to ask us, or what are they trying to figure out in this problem? We need to find the distance between points A and point C. So how can we do that? How can we identify the distance, or solve for the distance between points A and C? So that's the second step. The third step is going to be the solution. If we look closely at the given problem, we have here this clue. Okay, so AB is equal to 2/3 of BC, so we can write that down. So AB is equal to 2/3 of BC, or that's gonna be AB is equal to 2/3 times BC. And we know that AB is equal to x plus 3 meters. Okay, so we've substituted that given value there. And then we have here 2/3, and then BC is equal to 3x minus 6. Okay, so distributing 2/3 here on this right side, okay, so we can multiply that. That's gonna give us, okay, we can cancel that out. So that's 2x minus, okay, so what's 2/3 times negative 6? So that's gonna give us negative 12 all over 3. So that's gonna give us minus 4. Okay, and that's gonna be all equal to x plus 3. Okay, so solving for this problem, we have here x plus 3 is equal to 2x minus 4. Then we can transfer this positive x to the other side, and then this -4 to the other side, so that we have our constants on one side and then our variables on the other side. So we have here 3 plus 4 is going to give us 2x. Okay, so 2x minus x, and that's going to give us x is equal to 7. And there you go. So we've solved the problem. We found that x is equal to 7. So have we solved this problem? Okay, so if you think you've solved it, you can type it on the comment box. But I think we haven't yet solved this problem yet because we just found x. What we need to find is the distance between A and C. So how are we going to find the distance between A and C? So using one of the postulates that we've learned on our previous topic, on our current topic right now, we have the segment addition postulate. It says here that if we have two segments here, so that's AB plus BC, if we add them, so that's going to be total the entire segment that's shown here on the screen. So we have here AB plus BC is going to be equal to AC. Is that right? Okay, so if we have those two little segments, it's going to give us this big segment that we have there. Okay, so we know that x plus 3 is AB, and we know that BC is equal to 3x minus 6, and that should be equal to AC. Okay, so that's what we want to find, the measurement of AC, segment AC. And we know that the value of x is equal to 7, so we can substitute that here. So that's going to give us 7 plus 3 plus 3 times 7 minus 6 is equal to AC. Okay, there we go. And then if we add that, so that's going to give us 7 plus 3 is just 10. And 3 times 7 is going to give us 21. And then minus 6 is going to give us AC. So it's 21 minus 6, so that should give you around 15, right? So that's 10 plus 15 is going to give us AC. So therefore, what's the measurement of AC in meters? So segment AC is equal to 25 meters. Okay, so that's very near school. Okay, so therefore, the distance between Alexandria's house to her school is 25 meters. And we've solved this given